Alright, so I'm going to go through Chapter 9. So Chapter 9 is, of course, all about security vulnerabilities, threats, and countermeasures. So first we'll be talking about shared responsibility. Then we'll go into talking about client-based systems, server-based systems, as well as some integrated systems. Alright, so the idea behind shared responsibility is that the organization is going to work together. Okay? And this is working together both internally and externally. So for instance, there are very few organizations out there that don't have some element where they are going to receive an external product or service in some way, shape, or form. So with that in mind, what this is kind of talking about is you have lots of different employees who are doing things, and then of course you also have the organization using other external resources. So the shared responsibility comes in with who is actually responsible for problems that may arise inside of an organization. And in most contexts, that's going to end up being the higher-ups. So, you know, they always say that stuff runs downhill. And in this context, what we're referring to is the notion that, you know, the C-level is going to have more responsibility than the directors. The director is going to have more responsibility than the managers. The manager is going to have more responsibility than the average everyday employees. But it's not to say that there's one particular party who has 100% of the responsibility. So that's really the context we're speaking of, is who holds what amount of responsibility. Alright, so one thing you may be tasked with as an information security professional is actually going through and assessing a system's vulnerabilities. And there's a lot of different ways to do this. This is more of a general how-to as opposed to this is how you do it in every single circumstance. So consider what systems you're using. Okay, if you're using only Windows environment, probably don't be that concerned with the Mac OS problems. If you're using a more broad environment, you probably would be a lot more concerned with other sorts of problems you may arise. So always consider the problems and vulnerabilities for your specific environment that you're using. All right, this is going to be organizational-wide. It's not just for one specific person. It's not just for one specific functional unit. This is org-wide. All right, run vulnerability scanning tools. So when Corey did his talk, he talked about several different tools. For instance, stuff like Nmap, seeing what ports are open. Stuff like Nessus, you know, seeing what vulnerabilities are present. Okay, and you know, depending upon the results of that, consider how you may want to mediate them. It could be that there's a vulnerability, but you have to be on the local network to exploit it. That's going to be a lot less of a concern than one that has remote exploitation abilities. So use some common sense there. Look at stuff like the CVE and the CVSS scores to really give insight into how severe or unsevere something is. All right, and then of course, an important part of this is patch and replace systems as needed. So if you can patch a vulnerability and make it no longer be vulnerable, that's a great thing. But that's not going to be true in every single circumstance. So for instance, let's say that you're using a non-supported version of Windows. And let's say that the version of Windows you're using on the specific hardware cannot be upgraded. Okay? So let's say you're using an old P4 system. Let's just be honest, it's time to upgrade that. Shift gears over to the Mac side. Let's say you're using something that supports High Sierra 10.13. So maybe you're using a late 2009 iMac. It's probably time to upgrade. So if you can, patch. If you cannot, replace. All right, so hardware vulnerabilities. These are particularly more challenging because we don't necessarily have the ability to just run a patch and be done with them. All right, so this is built into the hardware, in other words. Now, a lot of times we can get away with just running a patch and being done with it. But this includes stuff like a backdoor, where there's purposeful access built in for a third party to be able to access a particular piece of hardware. Design flaws. It's more accidental than a backdoor, at least in most circumstances. But the idea is, just like before, if you can get away with running a patch, or not running, but applying a patch, that's going to be your best option. Okay, if you cannot get away with applying a patch, then you have to replace it. You could also isolate here, though. Isolation would likely be preferable in a lot of circumstances. So for instance, let's just face it, there's a lot of IP cameras that have known backdoors and known vulnerabilities where they're going to endanger any network they're on. Okay, so how do we mitigate that if we don't have the budget to replace the cameras? Because replacing cameras is not cheap. Okay, number one, you have to buy the hardware. Number two, you have to pay someone to install them. Okay, the combination of those two things does not lead to an inexpensive project. All right, so the obvious answer here is that what you would do in that circumstance, you would isolate it. So you put it on a completely separate VLAN and subnet, and in a lot of cases, you would disallow any communication leaving the camera. Okay, that's how you would do that in a lot of cases. So some other examples, CPU vulnerabilities. And we've seen like 5 major vulnerabilities in the past 5 years on the CPU side. The good news is that those can be mitigated pretty well through a firmware update and also through operating system updates. That's not going to be true all the time, though. Okay, using an old CPU architecture, there's a vulnerability with it. It's not going to be able to be patched in any way, shape, or form. So you have to be cognizant of that. All right. So if you've got a bad keyboard, all right, could be that it has a built-in keylogger, although more likely, let's say you're using an older wireless keyboard without encryption. Okay, that's a big problem. Okay, that can't be patched. Okay, there's not physical hardware in the keyboard to support encryption. All right, so you have to discontinue the use of the keyboard. Alternatively, I guess you could use it in a Faraday cage, although at that point you're spending a lot of pointless money to replace a $20 keyboard. All right, so use some common sense. All right, you don't want to spend thousands to build a Faraday cage to use a $20 piece of equipment in most circumstances. All right, client-based systems. So I put up here, they're usually installed and updated locally. By definition of client, they are going to be installed locally, but you're assuming that they have some sort of updates that are happening on a local basis. And this is going to be something that's going to be a pretty common structure. Okay, so in general, you have an organization. It may have, each employee may have its own workstation. All right. So if each employee has their own workstation, that's however many employees, plus some additional systems that you're going to have to be cognizant of. It's very broad, okay? Any one of those systems are bad, or they have some vulnerability that's not been patched, then that could theoretically be a vector. That would be quite easy to exploit. So how do we get around this? All right, do we just say no client-based systems? In some cases, that probably makes sense. But in a lot of other cases, it may make more sense to say we're going to have strong controls in place. So this includes having strong controls for update policies. So we have policies on all of our systems that are being used to ensure that we're constantly having updates run. And I don't mean constantly as in 24/7. We're checking every single second, okay? I mean, we're checking at a reasonable frequency, maybe once an hour. Okay, it's not going to interfere with work if it's happening once an hour. Disallowing installation, so having things like a blacklist is good, but if you're a big company and you're using a lot of locally installed stuff, it probably makes more sense to go with a whitelist. And in that context, it would probably make even more sense to go with an internal app store where you can only install applications through that app store or with IT approval. Sandbox. So again, this is going to be very difficult to do on, well, I shouldn't say difficult. It's going to be cumbersome to do on a lot of non-Windows based systems. Or let me rephrase that. On Windows-based systems, it's going to be difficult to do. Okay? Non-Windows based systems is built in a lot of cases. So particularly like .app on Mac OS, that's sandbox. .app on iOS, that's definitely sandbox. .apk on Android, sandboxed. I believe Chrome OS has everything run in a sandbox. Windows is not that way. Okay? So you could get away with doing some applications, host them out of Hyper-V instances. That's certainly a possibility. That's cumbersome. You could get away with doing some stuff through Citrix, maybe. That's cumbersome. So depending on your OS, it's more or less feasible. All right, just other policies in general. So having those strong controls is what enables you to protect a lot of this data. All right, so we're talking about server-based system a little bit. Okay, so the idea behind a server-based system is this is something that's centrally installed and managed. Okay, and that's going to have a lot of advantages and a few disadvantages. So we don't have to worry about having 4,000 or 5,000 different workstations. Okay, we have a handful. We have people who use them. They should certainly know what they're doing. They're interfacing with servers. They should be quite competent. They're probably not their first job. But this makes it a lot more valuable. Okay, so if you have a server, inherently it has more value than a regular desktop PC within a standard organization. So, hypothetically, if you have a server that's compromised, that's going to provide a lot more access to a potential attacker than it would to have a desktop compromised. So there's two primary ways we could approach this. The first is probably the more common for most modern infrastructure. It's going to be grid computing. The idea behind grid computing is it's laid out somewhat like a grid, where the load is distributed, but there's still a client-server model in place. Okay, in contrast, we have peer-to-peer. So peer-to-peer, there is no inherent client-server architecture. Everything's completely distributed, usually using workstations. All right, so common examples of that are stuff like file sharing technologies. That's often on peer-to-peer. Load balancing is something that we can use to have a lot of different advantages. Okay, it's not good to have a server that has 100% load 24/7. All right, because that's going to put a lot of strain on the server. It's also not good because that's a security risk. If one server is running 100% of your instructions, that's going to have a lot of downsides for things like system being able to execute code. Okay, so to prevent one system from executing 100% of code or whatever it may be executing, you'd of course use stuff like a load balancer to say divert and somewhat equally distribute the load between different systems. You could also do things like packet shaking. Okay, that's going to slow transmission down by design. It's very beneficial. It can be very beneficial. I really should avoid speaking in such absolute terms with this because it's not absolute in a lot of cases. So again, you have to have strong controls here, even more so than with your end devices. Okay? It's vital that these devices be protected, they be well updated, they have very strong access policies. You don't want anything bad to happen to your servers. All right. So industrial control systems, basically what this is for is operational technology. And what this means is technology that's used in operations that affect a large number of people. For instance, a factory. Okay, so if you have a factory that's running, presumably it's affecting a lot of people. Okay, think about current supply chain problems we're having. All right, some of that relates to factories not operating. When factories don't operate, it affects everyone. Utility providers. Think about the recent pipeline attack. Okay, that affected me personally. I was in Mississippi at the time. Okay, I don't know how it affected Colorado, but on the East Coast, gas stations ran out of gas. All right, the pipeline wasn't pumping. That's a big problem. Okay, believe me, that was a very big problem. So we certainly want to keep that in mind of what this is about. So, even more so than a server, okay, if you can get access to an entire industrial control system, that's a big thing. Okay, that's a very big thing, actually. That's a huge problem as well. All right, so we start talking about cyber attacks, and I don't want to go into that too much right now. But you can imagine that if a cyber attack were to take place on an industrial control system, that would not be good. All right. So 3 different things to know here. Okay. You have distributed control system. All right. And what that is that's going to allow you to control parts of a facility. And then of course you have programmable logic controller. That's usually going to be a device It's going to be installed in some operational facility, and it's going to be used to do things like open and close something, move a conveyor belt, those sorts of tasks. Okay, and then lastly, probably the most important thing up here is a supervisory control and data acquisition. So what the supervisory control and data acquisition system is, the system is going to aggregate all the data it gets from the distributed control systems, and it's sort of acting to really provide a single point of contact for controlling the facility. So if that's compromised, your facility is compromised. That's a very big problem. So this is also referred to as SCADA. Okay, so you may hear about SCADA attacks. And what that is, that's attacking the central supervisory control and data acquisition system in an organization. All right, so some other specialized systems. I'm going to run through these. I'm just kind of give definitions here. That's all you really need to know. Distributed systems. Okay, these are systems that are going to be out in the field. Okay, and a lot of times these are going to be operating more on a P2P as opposed to a client-server architecture. So for instance, stuff on the blockchain is distributed by design. Okay, anything running in peer-to-peer is distributed. It's not in a single space. It's everywhere. It can't be shut down. It cannot be censored. Cannot be controlled. At least that's the idea and the theory behind it. Okay. So high-performance computing, that's going to be quite common where you have a lot of times it could be a render farm. Sometimes this could be like an academic computing environment where people can run computational models and lots of good stuff. So it's generally speaking going to be like a server rack or server racks, full of servers, full of networking equipment, all tied in together to perform tasks that are very complex tasks. You don't ask it what's 2 plus 2. Okay, let's just be honest. This is sort of stuff where you solve very complex problems that you can't possibly solve. Well, I'm not going to say you can't possibly solve it, but most of these problems, very few, if anyone, could solve it without a high computing environment. All right, Internet of Things, pretty self-explanatory. Devices that are distributed and not necessarily traditional computing devices. So let's back up and give the definition of a computer. Okay, user-accessible file system, as well as something that you can use for computing tasks. Okay, so IoT may be a door sensor. Okay, it may be your washing machine. Okay, it may be your oven. Okay, any device that's not a computer that's still connected to the internet to perform, maybe updating you with stuff, whatever. Okay, and lastly, embedded devices are going to be embedded controllers that allow you to control things. A lot of times, like a smart thermostat could be an example of an embedded device. Okay, it's also an example of IoT, most likely, but not necessarily. Okay, so an embedded thing just refers to having a single computing device on a single printed circuit board. Okay, so it's embedded. It has a dedicated purpose. It's not necessarily a computer, although it can be. I said computing device because it can perform computations. However, does not likely have a user-accessible file system, at least not in the traditional sense. All right, mobile devices. You may be thinking, well, Andrew, I know all about cell phones. Why am I talking about this? Well, it's important to understand that organizations may have the need for people to not just be sitting at a desktop all day. Okay, in classrooms like we have here, labs especially, you're sitting in front of a desktop. That's not necessarily how work takes place. Even 10 years ago, that's not necessarily how work took place. People go off in the field. Okay, so a lot of times these devices are not going to be on your corporate network. So maybe you give someone a laptop and they take it home. Then they take it to China on a business trip. Okay, so they take it to China. Okay, and when it's in China, you don't know what's happening to it. So you certainly want to think about it in that perspective. Okay, off your corporate network, you don't have nearly as much control over these, ceteris paribus at least. So some different things you may do to mitigate that. Okay, have an always-on VPN. Okay, that's probably the biggest thing you can do. So if you're a company, chances are you already have the ability to use a VPN in some way, shape, or form. Okay, this could be a dedicated appliance, could be a server you could spin up and run. Hey, whatever. All right. Application control. Again, just like with what we talked about, this is vital. Okay, you don't want just anything to be able to be installed on company-owned devices in most circumstances. Okay, because if you allow that, what you're really doing is you're allowing anyone to install anything. And if you're talking about on a rogue network, you're talking about not just the end user installing stuff, you're talking about the network installing stuff. So that could be a very big problem. Of course, if you're on a VPN, you're going to mitigate a lot of that just by being on a VPN. All right, device control. Okay, stuff like remote wipe. Okay, so if you set up an Exchange email account, okay, a lot of them are going to say, hey, we have these policies. These policies often include stuff like you have to have a PIN code set on this device. You have to allow remote wipe of the device. All right, and that makes some people nervous because they're thinking, well, I don't want my stuff to get wiped. But really what that is, if you're on a device like that and you have, let's say it's an Exchange device, or a device using Exchange rather, you can sign into your Office 365 account, you can figure out the devices associated with it, you can just click erase, you know? So that's the sort of thing you're talking about with device control, being able to do those anti-theft measures, and more importantly than anti-theft, because let's face it, you're a multi-trillion-dollar company, you're a multi-million-dollar company even, you know? You don't care about losing a piece of it. I mean, losing $1,000 it's bad, but it's not the end of the world bad, okay? So what we're talking about in this specific instance is, you know, the idea that we can lose some amount, all right? But losing data is a lot more costly than losing a $1,000 device, all right? Now, having said that, I as an individual, I certainly don't want to lose a $1,000 device, all right? I don't think I own any devices that are worth $1,000, but even if I did, I certainly wouldn't want to lose it, all right? So another key thing to talk about here is a mobile device manager. And the idea behind a mobile device manager is it's something that has devices enrolled in it, and it's going to allow you to push out policies to devices, pretty similar to stuff like Active Directory's group policies. However, this has some important differences. Right? It's not specific on being on a corporate network. Okay. There's also a lot of additional things you can do, and a lot of different types of devices. So group policy, for the most part, pretty limited to Windows. All right. Technically speaking, not entirely limited, but you know that's a big discussion. Now, in contrast, when you start discussing, mobile device management, they can support pretty much any widely used platform. If you have Chromebooks and you're in a K-12, probably have them enrolled in an MDM. Okay, you can track stolen devices with them. You can control what's installed on them. Just a multitude of things you can do, and it's very useful in that context to be able to do those things. All right. So, just kind of wrap things up. It's a shorter lesson. Just want to kind of hit the high points of some of this stuff. Talked about shared responsibility, what that looks like from an organizational perspective. Talked about client-based systems. Also talked about server-based systems as well as integrated systems. So I'm going to wrap it up. See you all in the next class. Have a good one, everyone.